Okay, so salam sejahtera and very good morning, guys. So today we will talk a little bit on the modifications to the mixed design method, or what we call as modify replacement method. Yeah. So this is the continuation from the topics where we have left since last week on the basic DOE mixed design. So at the end of the course, you should be able to modify, okay, and also understand the mix design by incorporating chemical and also mineral admixture. So before this, in the topics of the admixtures, we have already designed on the air-entrained, okay, air-entrained agents or air entrainment. Yeah. So when we are designing the concrete mix, which incorporated these admixtures, uh, we have to take into considerations the effects from the entrained air on the strength, workability, and also the density. Okay, so those are the things that we are going to discuss one by one later on, and then just to refresh. So what are the effects of the entrained air on the strength? So generally, the concrete strength is reduced by the additions of the entrained air, and because of the air bubble, it will render our cement less dense compared to the conventional concrete, and it approximately loss of 5.5% in strength will result for each 1% uh, by volume of air entrained in the mix. So which means that if we add 1% of the air entraining agent, it will result in the 5.5% loss in the compressive strength, right? So in order to take into this side effect into considerations, this is the formula that we are going to use, where the FC is the specified strength plus the margin, and then you have to divide it by 1 minus 0.055 A, where A is the percentage of the volume of air entering. So what are the other effects from the entrant air on the workability? Aside from its strength, it will slightly increases the workability, and then it modifies the character of the fresh concrete, making it more plastic and cohesive. So a reduction in fine aggregate by up to 5% of the total aggregate. So this is the consideration that we will put into our mix design later on. And then during we perform the mix design for the entrained air concrete. So the effects of the entrained air on the density is also need to be taken into considerations, because the density of the concrete will be slightly decreased due to the air bubble. Due to the air bubble. So in the case of the air entrained concrete, after determining the density value from the chart, this is the chart uh, which we refer when we are performing the basic DOE method. The correct value is obtained by subtracting the calculated value of an amount of 10 multiplied by A and multiplied by RDA. So what actually is A? A, like what we have already discussed earlier, is the percentage of the air entrant, whilst the RDA is the relative density of aggregates, which is calculated based on the SSD basis. Okay, so the modifications to the design process generally, it is a little bit similar with the normal method, except for the changes needed to be addressed through target mean strength, free water content, and also concrete density. So the modifications due to the entrant air. So this is the conditions where we have FC, which is equivalent to 13 Newton per millimeter square at 28 days, and the defective rate is in these questions we use assumption of 1% equivalent to K 2.33. Yeah, and then we use the cement, which is OPC. The slump we just assume is 25 mm, so that is our targeted slump, although this is not logic, like what we have already discussed earlier. And the maximum aggregate size that we are going to use is 20 mm, and the maximum water cement ratio is 0.55. Minimum cement content is 285 kg per meter cube, and air content is 4.5%. And so this is the percentage of air-entrained agent that we are going to use. And the previous control data gave the standard deviations of 5 Newton per millimeter squared. So for the aggregates, course we are using the crushed aggregates. Fine aggregate we are using the uncrushed, and the aggregate relative density is equivalent to 2.65 fine aggregates with 50% passing 600 micrometer sieve. So what are the modifications that we are going to do? Actually, there are only 3 modifications. So in the stage 1, item 1.4, okay, it is modified to allow for the air content, okay, and then in the stage number 2, item 2.3 involves the calculations of water content as per table 3, okay, as per table 3, and then in stage 4, which is item 4.2, the wet density of the concrete is adjusted for the air content. Yeah, so this is the example. All right, so we move on to the modified replacement method when we are adding the PFA, in our concrete. So what actually is the PFA? PFA is the pulverized fuel ash. And so why we use PFA in the concrete mix, we have already discussed before this in the admixture topic. So basically, it replaces some of the cement, okay, and then it reduces thermal cracking problems in massive concrete sections. And then it is good with concrete that is placed in sulfate-bearing soil. Okay, so there is a tendency for the sulfate attack, and it is useful when there is a chance for the alkali silica reaction to happen in the concrete. Okay, so the modifications to the mix design is 5 items, okay, that need to be considered. The first one is the workability and water cement ratio, because the adding of the PFA will adjust or modify, a little bit of the water requirement, and then the strength and also the free water cement ratio. Third one is the cement content, and then the fourth one is the variability of the concrete strength, and the last one is the density of concrete and aggregate strength. All right, so these are the modifications that we are going to do. But before that, we need to know what are the things or the symbols that we are using in the modified replacement method. So the first one is W, which is the free water content in kg per meter cube. And then the C is the Portland cement content, kg in meter cube also. F is the PFA content, and P is the proportions of PFA. Okay, so the design procedure similar like the entrained air concrete. The procedure are similar as normal concrete, but only a few adjustments are required. So the first one is we have to adjust in terms of the water requirement. So the water cement ratio we have to be changed from the existing WC to W over C plus 0.3 F. Okay, and then the free water content is obtained from the table 9 part A for the maximum size and types of coarse aggregate to be used. So we will show later on. And meanwhile, for the cement, there are also some modifications that we need to do. Portland cement content is determined from C, which is determined using this formula, which I'm going to show you later on. And the PFA content is determined by using this formula. Meanwhile, for the aggregate, total aggregate content is the density of the concrete minus the cement plus F, which is the cement plus the PFA minus the water. Okay, so D is the wet density of the concrete, and then fine aggregate content is the total aggregate content times the proportions of the fine aggregate. So this is your assignment question for assignment number 2. So you have to design a PFA concrete mix using the following info, where you have the FC, which is the characteristic strength, 45 Newton per millimeter squared at 28 days. The cement type used is OPC, and then the PFA is according to the BS 3892 part 1. Yeah? So PFA is equivalent to 35%. Slump is 60 to 180 mm, and the maximum aggregate size to be used is 20 mm. Meanwhile, the maximum free water cement ratio is 0.6, cement content 300 kg per meter cube, and then from the previous control data, the margin of 12 Newton per millimeter square is required. Aggregates uncrushed for both coarse and also fine aggregate. So the relative density is 2.6 and the fine aggregate is 70% passing 600 micrometer sieve. So you need to submit this assignment number 2 in our e-learning before the 4th of May. Okay, before the 4th of May. Okay, so please take note. Okay, so this is the example on how are we going to conduct the what we call the modifier replacement method with the considerations of the PFA. Yeah, so the question is design a PFA concrete mix using the following info, where you have the characteristic strength of 35 Newton per millimeter squared at 28 days using the OPC for the cement types, and then PFA also according to the BS 3892 part 1, and then the PFA is 30% slump 10 to 30 mm, maximum aggregate size 20 mm, maximum free water cement ratio 0.6, cement content 300, okay, and the rest is the same with your assignment. So we continue. So this is how it looks like. So actually, this table or this sheet, this design sheet can be obtained from the BRE design manual. So we look into this one by one. So this is the conventional mixed design sheet. Okay, so I believe you all have already familiar with this. Okay, so characteristic strength, if according to the questions we put 35 at the end of 28 days, so proportion defective we no need to calculate because from the control previous data it's already been specified 12 Newton per millimeter squared is the margin. So targeted mean strength 35 plus 12 you get 47, and then the cement strength class we pick 42.5 plus the PFA in both the aggregate types for coarse and also fine aggregate are encouraged. And then starting from this 1.7 to 1.8 we need to use the PFA sheet. Okay, so this is how the PFA sheets look like. So in the PFA sheets also it have the corresponding stage 8. So from stage 1.1 to 1.4 you need to refer to the standard form, which is this form and the previous form. Okay, and then for the cement strength class we specify 4.2 plus the PFA. 1.6 is also from the standard form, which is this the aggregate types. All right, and then the free water cement ratio we need to refer to table 10 and also figure 4. Okay, so if you look at here, so this is table 4, so table 10. So this is the approximations of the compressive strengths of Portland cement or PFA met with the WC water cement ratio of 0.5, 0.5. So the cement strength class, which is 42.5, the type of aggregate we used uncrushed, the compressive strength at 28 days is 42, right? So at this line, so for this line, which is 0.5, 42 is somewhere around here, So we draw a new line. Okay, we draw a new line. Okay, so the targeted strength, if you look at here, targeted strength is 47. So 47, we draw a line. Okay, draw a line, and then we meet the line over here. It is somewhere around here. Okay, so we can use the water cement ratio with this, which is 0.46. Okay, so once we have completed the stage 1, so we move on to the stage 2. So at here you can see I have put the conventional design sheet. So this is the conventional one. Okay, and then this one is the design from the PFA sheet, right? So the slump and the VB test we use 10 to 30 mm. Okay, and then for the maximum aggregate size we are using 20 mm. All right, and then the free water content we have to use the PFA sheet, which is this one. Okay, so if you look at here, the 2.1 and 2.2 is from the standard form, and then the proportions of the PFA is already been specified, which is using 30%. All right, so from the free water content, we have to refer to the table 9, which is this one. Okay, so this is the approximate free water contents required to give various level of workability. So if we are using the 10 to 30 mm of slump, and then the maximum aggregates is 20, and then we are using uncrushed. So the approximate free water content is 160. Okay, it's 160. So if you look at the part B, so part B actually is the Portland cement plus the PFA concrete. Okay, so if you look at here, the slump is 10 to 30 mm. All right, and then the proportions of the PFA that we are using is 30. Okay, so at here we get the figure 15. So what actually is 15? Yeah, so 15 is the reductions in the water content. So what we need to do is that we have to use the 160, which is from the conventional concrete design, minus the 15, yeah, for the PFA concrete. Okay, so 160 minus 15, you get 145. Okay, and then we proceed to the stage number 3, where for the maximum for the cement content, okay, the minimum cement content is specified in the in the question, which is 300 kg per meter cube. So uh, for 3.1, for 3.1 to 3.4, we no need to calculate. We straight away calculate starting from the 3.5, which is from the PFA sheet. So the Portland cement that we are using, C6, C6 is we calculate using this equation. So we just plug in the input figures, yeah, and then you calculate based on this formula, and then you will get the cement, which is 280. PFA content, we have to calculate using C7. C7 is this formula, okay, which we already discussed earlier. So you will get the F, which is 120. So total of the cementitious material is C plus F, which is 280 plus 120, you will get 400. Okay, so 3.2 to 3.4 is calculated in the basic DOE. Okay, in the basic DOE, we have already had included all those input, and then the W, okay, W divided by the C plus F is W is the water content, which you obtain from the stage 2, divided by the C plus F, which is 400, and you will get 0.36. Okay, and then the specified maximum water cement ratio has been given in our question, which is 0.6. So since 0.36 is lesser than 0.6, then we have used this 0.36. So since the relative density of aggregates is 2.6, okay, it has already been given in the questions, and then we have to determine the concrete density, which can be obtained from the figure 5. So I did not include the figure 5 over here, so you can refer back the figure 5 from our from the basic DOE method. Okay, so from that figure, actually we can get the density, the wet density of the concrete, which is 2,420 kg per meter cube. Okay, and then the total aggregate content we have to calculate using the PFA sheet, which is 2,420 minus the W plus F, which is 400, and then minus the water content. The cement content. Cement content. This is cement content. C plus F. So this is water, and you get 1,875. Okay, and then the procedure for the fine aggregates is similar. It's exactly similar with the previous one for the basic design, concrete mix design, which is you put 70% of the percentage passing 600 micrometer. Okay, and then from the figure 6, you get 26% of proportions of fine aggregate. Okay, and then you do the calculation correspondingly, and you will get the mixed proportions for the PFA concrete. Okay, so that's all for today. Thank you.